Section 5.4, dividing polynomials and synthetic division. And in this section, we're going to be using this to find factors of polynomials. There's other ways of dividing, but we're going to focus solely on synthetic division, which is very quick and easy to use. So let's get started. Next. All right. So a polynomial divided by a monomial is when you take a polynomial like this divided by a single term, okay? Some people have issues trying to see what all they need to do, so you can rewrite this as 3a squared b divided by 3ab plus 6a3b squared divided by 3ab plus 18ab divided by 3ab. So you can take each one of these terms and divide it by the denominator. Okay, when you do that, just remember your quotient rules. You divide your coefficients. 3 divided by 3 would be 1. And then you subtract your exponents. So that's a2 minus 1, so that's going to give you a. 6 divided by 3 is 2. And then 3 to subtract 1 is 2. b2 subtract 1 is b. 18 divided by 3 is 6. AB divided by AB is 1, so it's just 6. Alright, so it can be written either way, but you know, if you can see it this way, you don't have to write it out that way. But it's very easy to divide and come up with your equation from there. Alright, so that's if it's a polynomial divided by a monomial. But using synthetic division, we're going to be doing a polynomial divided by a binomial. Remember, binomial is a two-term polynomial. With synthetic division, there's a lot of steps. It sounds like a lot, but it's very, very easy. Method used to find the factors of a polynomial given one zero or one factor. All right, if it's given a factor, you solve it for 0. So in other words, this is what they gave us to begin with, x minus 7, that we're going to divide by. Well, we have to solve that for 0 to get a solution to divide by. So you would just set this, let me change my pen color. You would change this, x minus 7 equals 0. Add 7 to both sides, then x is 7. That is what goes in this little box out here. Okay, that's going to be your divisor. Alright, so what you'll do when you set this up, you always want to have your polynomial in descending order by the x's. Okay, and this is what we're dividing. Alright, so this goes 3, and then 1, and then none as far as degrees. Well, when you have that, you have to have it in descending order. If you don't have a degree, like in this case, we don't have a second degree x, you put a placeholder. Okay, so this coefficient right here is 1, so I'm going to put just the coefficients down. I don't put any letters, just the coefficient, with whatever sign it is. I didn't have a second degree, so I put a 0. Then I have a negative 57x, that's a first degree, so then I'm going to put my negative 57, and then 56 is positive, and that's just a constant. Okay, once you have your coefficients there, then you can go ahead and start the process. But remember, if it doesn't have a degree for every single place, you need to put a 0. So this is 3, 2, 1, 0 degrees. And that's the way I always double check mine. I always go back and go 3, 2, 1, 0. Okay, good. Now, the very next step, whatever the first coefficient is, you just bring it down. Okay? You don't do anything but just bring it down. From here, you're going to multiply whatever is your divisor to that first coefficient. So 7 times 1, which is 7, and you're going to put it right here. Okay, then you're going to add vertically. So 0 plus 7 is 7. Now, you're going to multiply the 7 to the new number down here. So it's 7 times 7, which is 49. That goes right here. And then you're going to subtract. You're going to have 57 and 49, you're going to end up with, whoops, -8. Okay, and then you're going to multiply these 7 times the -8, which will give us -56. Now, the last block will always be your remainder. And I kind of always mark it off to the side so I'll recognize that's the remainder box. My remainder on this one is 0. Okay, so you have a 1, a 7, and a -8. When you write your polynomial that you formed from these coefficients, it's always going to be one less degree than what you started with. We started with a x to the 3rd power, so our answer has to be starting with the 2nd power. All right, so that would be a 1 right there. All right, and then you go down in descending order. So that's 1x squared, and it's a +7, and then we're going down. There's our x. So there's 2, 1, and so the next thing is our constant. Okay, so this is just our constant. And once we've got all the degrees represented in descending order with a remainder of 0. Okay, so you just multiply. Let me change the color. Maybe you can see as I do it. You go bring this 1 down, and then you do 7 times 1 and put it there. Then you do 7 times the 7 right there and put it there. 7 times this and put it there. So it's kind of a zigzag. You'll go 7 in this and then add. 7 times whatever and then add. It's really not easy. It is easy. It's really not complicated at all. All right, so now make sure you have it in descending order and it's 1 degree less than your original problem. All right. Now, in the previous problem, we found there to be no remainder. That meant that x minus 7, which is what we were dividing by, was a factor, okay, factor of x cubed minus 57x plus 56. We used the synthetic division method and found the answer to be x squared plus 7x minus 8, which we can factor to get the remaining factors of that polynomial. So, if I have x squared plus 7x minus 8, all right, we say factors of 8 that subtract to be 7, split up your x's. You know, because it's a minus back here, one's positive, one's negative. All right, factors of 8 that subtract to be 7 are 8 and 1. So right here tells us that the 8 has to be positive. Okay, so now our complete factors then for the entire polynomial that we started with, x cubed minus 57x plus 56, the entire factors that make that polynomial are these two plus the one we divided out. So that's x minus 7. So if you were to multiply all those together, that's what you would get, x cubed minus 57x plus 56. Therefore, those are the factors. From there, you can sketch the graph. If you have all your factors, you can go ahead and sketch that graph. Remembering that each one of these factors set equal to 0 will give us the solutions or the roots or the x-intercepts. So that would be a 7, that would be a -8, and that would be a +1. And that's where you would take and put points on the x-axis. So at +1 and at -8, 2, 4, right there. 2, yeah, making sure. And then +7, so that's 2, 4, right there. Okay? Now, this is a cubic, so we know it's got to be a S shape. It's positive, so it has to look like that in some way. So we need to be going left to right, and we need to be going up. So I'm going to go through my point because it is a multiplicity of 1. That means it goes through the point and somewhere, some way like that. Now, is that exact? No, but we could find it if we needed to. We could plug in 0 and get our y-intercept to be -8. Okay, so you can plug it in and get the exact, but it's definitely going to go through those points. They're all a multiplicity of 1 because it did not repeat any of them. So it went through all of those. Okay, so we can easily see once you've graphed the end behaviors, the intervals where it's increasing and decreasing. You can look at domain and range, and remember cubics, domains, and range are all reals both ways, okay? Always. And then relative max and mins. If you had it graphed exactly, you would be able to see exactly the relative max and mins. So, but notice, that's because we had x minus 7 left as a remainder of 0 when we divided. Sometimes when you use the synthetic division, you won't always have an answer without a remainder, okay? That means you're going to have some possibly irrational answers, okay? But this one worked out really nice. Then you can use this to find out certain factors. You can, guess if you needed to and see if that works and see if it's a 0, okay? So let's do one where it doesn't work out so pretty. Alright, so this one is x cubed minus 7x squared minus 7x plus 20, and we're going to divide it by x plus 4. Okay, so I'm going to, remember the divisor, we make it x plus 4 equals 0, so x is -4, or you just know, like I've told you before, everything inside parentheses is always the opposite in algebra. Alright, so it's -4 is going to be your little divisor, and it goes in the box out here. Then you write your coefficients. Well, the coefficient of my x cubed is 1. Then it goes 3, 2, 1, and 0. So we don't have to put any placeholders. The next one is a -7. The next one is a -7. And the last one is 20. Alright? You're going to bring down your first term, okay, and then you start multiplying. -4 times 1 is a -4, and now we add -7 plus a -4 is a -11. Then we multiply. -4 times a -11 is positive 44, and then we add, and we should get 37. And then -4 times 37, which is a -148. And then when we add, we get the remainder. Remember, the last box is the remainder, and that's -128. Right? And then we write our polynomial. Again, we started with x cubed, so the very first one will be an x squared, one less. So we take our coefficient, that's going to be 1. Minus 11, and the next one down is x, plus 37, and that doesn't have an x, okay? And then it has a remainder of -128. Sometimes you'll, excuse me, sometimes you'll see this as -128 over x plus 4, okay? So all this plus this. Okay? So this is your remainder. Alright, so this is how you do long division. It's very simple to set up. Just take your coefficients, do it in descending order. If you don't have a degree, you have to make a placeholder. Bring down the first one, multiply and add, multiply and add, multiply and add. And then it's the 1 degree less when you multiply. And this one will not factor. You can't do factors of 37. That add to be 11. So this one did not have x plus 4 as one of its problems that works out to make it factorable. Okay? And that's all. We will practice a lot of this in class. It's useful when you go into pre-cal, so it's an easy technique to do. And let me know if you have any questions.